Good morning, students. Today we are going to start exercise 9b. So as per our last class, we have already finished up to question number 3. Now today we will start from question number 4. Okay, so now in question number 4, the first question is 4122 is divisible by 2? So now question is 4122 is divisible by 2? Now we have learned in the divisibility test that if the last digit of a number is even, then that number will be divisible by 2, isn't it? So since we can see in 4122 the last digit is 2, that is an even number, that means we can say yes, 4122 will be divisible by 2. So here you will write, see here how you will write the answer. You will write yes 4122. So number A you are right, you will write yes 4122 is divisible by 2. Okay, and in the next question, another one is 3646 is divisible by 2? So now since 3046, here also the last digit is 6. So if the last digit is 6, that means it's an even number, and we know even number is always divisible by 2. So here also we'll write yes, number is 3646 is divisible by 2. Now number C. Number C is, question is, will their difference also be divisible by 2? And question number D is, will their sum also be divisible by 2? So will their difference means these two numbers difference, and sum means these two numbers sum. So here you should know that sum of two even number is always an even number, and difference of two even number is also always an even number. So since the sum as well as the difference both will get as even number, so both the sum and the difference also will be divisible by 2. You understood? Without without knowing you cannot write. Okay, and in this divisibility test we will not do the actual division also. So we need to write with the help of the divisibility rule what we have learned. So here, see, by looking at the last digit we can say it is divisible by 2. Now one more thing we have learned just now, that if the if the two numbers are even number, then their sum is also an even number, and if the two numbers are even number, then their difference is also a even number, and even number is always divisible by 2. So here we will write yes, the difference, what we will write? Yeah, their difference, yes, their difference is also, yes, their difference is also divisible by 2. Number D, yes, their sum is also divisible by 2. So hope you have understood. Okay, we should know this and we will write. So this is question number 4. So now the question number 5 is, find without actual division which of the following numbers are divisible by 4. Tick them. So to do this we need to know the divisibility rule of 4, isn't it? We need to know the divisibility rule of 4, and since here it is it is already given that without actual division we cannot do the actual division. So without actual division we need to do. So in A the number is 72. Okay, now the divisibility rule of 4 we have learned as if the last two digit of a numbers are 00 or a multiple of 4, isn't it? This one we have learned as the divisibility rule of 4. So if the numbers are 2-digit number, then we need to check the multiplication table of 4, means whether it's a multiple of 4 or not. So since 4 18s are 72, 4 18s are 72, so it is divisible by 4. Number A. Number B is also a 2-digit number. Actually the divisibility rule applies better in the larger number. Okay, so in single digit or 2-digit number, this is not applied so correctly, but still we need to check it here whether it is divisible by 4 or not. So we will go for the multiple of 4. So we can see here 96 is also divisible by what? 96 is also divisible by 4, since here 4 2s are 8 and 16. So 16 4, 4 24s are 94, 4 24s are 96, so it is divisible by 4. Now just have a look on question number C, D and all other things. You see in question number C, the number is 124. Now you see, so we need not to check the whole number. We will see only the last 2 digits. Since last 2 digit is 24 and we know 24 is a multiple of 4, 4 6 are 24, so we can say yes, 124 is also divisible by 4. Now after C, let's move to question number F. The number is 930. So since we have 30 in the last 2 digit and we know that 30 is not divisible by 4, so we can say 930 is not divisible by 4. Okay, so A, B, C, then F we did. Now let's move to question number H, where we have 2400. Is it? Yeah. So here we have the last 2 digit as 00, and we know if the last 2 digits are 00, then it is divisible by 4. So hence we can say this 2400 is also divisible by 4. After H, now let's move to question number K. In question number K, the question is 26,410. So since 10 is not divisible by 4, we can say that number is not divisible by 4. So in this way you need to do. Okay, so here I did 36 maths, and here rest of the maths you will do at home. Okay, now after 5, let's move to question number 6. Now in question number 6, write down 10 numbers greater than 800 and less than 900. So 800, greater than 800 and less than 900, we need to write 10 numbers which are divisible by 4. So you can write any number in between 800 and 900. Yeah, you can write any number in between 800 and 900, but if we apply a small trick, then we can write it first without any hesitation. See, we need to write 800 in between the numbers of 800 to 900. So if we start from 801, okay, if we check, so we need to check also those numbers. We will write only those numbers which are divisible by 4. So if we write 804, 808, 812, why I am writing this? Actually I am writing all the multiples of 4 after 800. If I write all the multiples of 4, that means all the numbers will be divisible by 4. Okay, 812, then 816, like this 10 numbers. Here I have written 1 2 3 4, rest 6 numbers you will write. Okay, so in this way we will write only the multiples of 4 in between 800 to 900. So now this is 6 number, and now same as question number 7 also. In question number 7, write down 10 numbers greater than 7,420 but less than 8,000 which are divisible by 4. So the numbers we need to write 7,240 greater than 7420 and less than 8000. Okay, so now again if we start here, you see, no, from this number if we start after 20 all the multiples of 4 if we write, and how many multiples we need to write? We need to write only 10 numbers, so we can write it easily as 7424, 7428, 7432, 7436, 7440, in this way. So 1 2 3 4 5 I have written, rest of the numbers you can write. Okay, so in this way we can do question number 6 and 7. Okay, so in this way we can do question number 6 and 7. Finished. Now after 6 7 let's move to question number 8. 8, the question is, find without actual division which of the following numbers are divisible by 3. Now we need to check the divisibility rule of 3. So in question number A, the number is 87. Now before starting this math we need to recall that what is the divisibility rule of 3. So what is the divisibility rule of 3? If the sum of all the digits of a number is divisible by 3, then that number is said to be divisible by 3. Yeah, the video is doing very disturbance. Now see, here we need to check whether 87 is divisible by 3 or not. So what is the divisibility rule of 3? That if the sum of all the digits of a number is divisible by 3. Okay, so what are the digits here? 8 and 7. So let us see the sum. So 8 plus 7 is 15. Since 15 is divisible by 3, we can say 87 is also divisible by 3. Okay, so what we need to write? Find without actual which of the following numbers are divisible by 3. So here we will write yes, 87 is divisible by 3. Like this you need to write. First of all you will check in this way and then you will write yes, 87 is divisible by, let me show you once. Yes, 87 is divisible by 3. So in this way you will write in all the numbers. Now from next one I am not going to write this line, you need to write in your copy. Okay, I will just show which numbers are divisible and which numbers are not divisible. So after A, now if we move to question number D, where the number is 515. 515. So what we will do, we will check the sum of all the digits. So what are the digits? 5 plus 1 plus 5. So what is the sum? Sum is 11, isn't it? 5 plus 5, 10, plus 1, 11. So since 11 is not divisible by 3, 11 is not divisible by 3, so 515 is not divisible by 3. Understood? So after A, D, then let's go for F. In F, the number is 810. So now here we have 8 plus 1 plus 0 is equals to 9. Since 9 is divisible by 3, so 810 is also divisible by 3. After F, now let's go for question number G. In G we have 1240. 1240. So 1 plus 2 plus 4 plus 0, isn't it? 1 plus 2 plus 4 plus 0. So 2 plus 1, 3 plus 4 is 7. Since 7 is not divisible by 3, so 1240 is also not divisible by 3. Okay, so this is F, G. Next, so this is F and G. Now after F and G, now we need to move . So we did up to F and G. Now let's move to question number I and L. So I, 7413. So here the sum will be 7 plus 4 plus 1 plus 3, isn't it? So you see 3 plus 1 4 plus 4 8 plus 7 15. So since the sum is 15 and that 15 is divisible by 3, so we can say 7413 also will be divisible by 3. Is it? Yeah. Now after after I, let's go for L. The number is 91,002. So the sum is 9 plus 1 plus 2. 9 plus 1 is 10 and 2 12. Since 12 is divisible by 3, we can say 91,002 is also divisible by 3. Okay. So in this way we will do up to question number 8. Rest of the maths we will do in our next class.